In the last video, we understood what are polynomials as a quick backdrop for understanding partial fractions. In this episode, we will try to understand what exactly are partial fractions and what exactly we do when we're trying to solve problems related to the partial fractions. So let's understand one of the important terms in this context, something called as rational expressions or like rational expression. And all these terms, whether it's polynomials or rational expression, sorry, you guys would have already encountered this or learned about this in elementary school, or maybe even prior that, or maybe in the secondary school around 7th or 8th grade. So but back then we don't really keep focus and we just focus on solving. So let's do a quick refresher on what is a rational expression, like we did in the last episode, a refresher on polynomials. So rational expression is nothing but when you have a ratio of two polynomials, a ratio of polynomials. There is some polynomial in the numerator and there is some polynomial in the denominator. And this whole expression is called as a rational expression. That's what it means in simple language, okay? And I put some examples over here. If you see numerator, although it looks like a constant, it's a polynomial with an unknown variable raised to the power 0, which is what we saw in detail in the last episode when we were discussing about polynomials. That's what we saw. Over here, if you see again, there is a polynomial here in the numerator and there's a polynomial here in the denominator. And same way over here, they are of varying degrees, but we'll come to that later. But any expression where there is a numerator and there's a denominator and both are expressed as polynomials is called as a rational expression. That's what it means, okay? And now let's check out what exactly we do when we try to solve the problems related to rational expressions or partial fractions, okay? Before that, let's understand, like we have learned in the elementary maths, how do we typically add or subtract two rational expressions? For example, we have one rational expression over here and one over here, which is 3 upon x plus 2 and 5 upon x plus x minus 1, and we're trying to add both of them. So in basic maths, which we know, it's very easy, but the whole partial fractions notion is structured around this. So it's very imperative that you guys should know what we are trying to do here. When we're trying to add these two rational expressions or RE, like let's call it RE, okay? So what are we trying to do here? All we're trying to do here on the right hand side is basically we are taking a common denominator, and that we do by taking the LCM, which is the very primitive or elementary level maths where we take the LCM. And how do we do that? We take the first term and over here, and pretty much we cross multiply it, this and this, we cross multiply the terms and make the denominators common. And for that, what we do is over here we have x plus 2 and we don't have x minus 1. So we multiply and divide by x minus 1. And over here in the original expression, we had x minus 1, but we don't have the other term. So whatever term is missing, we just try to multiply and divide to balance it off. And then what we do is we take the common denominator and cancel out. In this case, if you see, when you expand this becomes 3x minus 3. When you expand this, 5 into x plus 2, 5x plus 10. And the denominator, because of the LCM effect, it becomes common where you have x plus 2 multiplied by x minus 1 on both the sides of on the right hand side, and which is what we also have on the left hand side pretty much, okay? And then what you do is, now since the denominator is same in this step, you can add the numerators as it is. So you add this term and this term over here like this, and then you simplify to get this final term or combined expression called as 8x upon 7 and x by 2 and x minus 1. So this is also a rational expression, and this is not simplified. Whatever was given to us was simplified, and we have kind of did some algebraic computation taking LCM, cancelling out the denominator and all those things, and we have come out with a combined expression which is in this format. So we started with something which is more of a simplified version of a rational expression, which was given in a very simple format without any complication, and we kind of did the algebraic mathematics computation, and we came up with a relatively more complicated or combined or unified version of expression over here. That's what we did, and this is where we ended. And that's how typically we do when we add or subtract two or more rational expressions. So partial fraction is nothing but the exact opposite of this. So you started from here in this case and you ended over here. In partial fraction, you do the exact opposite. What you do is, I've just copied the same thing over here. In terms of adding and subtracting rational expression, we started over here and we ended over here getting this. In case of partial fraction, this will be given to you as the input, and our objective is to take this expression, which is relatively more complicated than the given expression, and do some magic, which is way the algebra or the mathematical part of partial fractions work. And our objective is to come back to the starting point where we have the simplified version of the partial fraction. So we start from here. In case of all examples or problems related to partial fraction, we start with the combined or a relatively more unified or complicated rational expression. And our objective is to do some magic to simplify it and bring it back to the simplified version to start with, which is what we would have done when we added the or subtracted the equations earlier, the example. So the opposite effect of that is what partial fractions are all about. We start from here, the starting point, and this is the ending point. And if you see in this red color, I put the definition of that. What does it mean? Going in the reverse order, start with a rational expression, one combined fraction, which is what this is in orange color, and ending with a simpler broken down parts. In partial fraction, it is also called as decomposition or decomposing. You're decomposing this, you're breaking it down into simpler fractions. So this part, if you see, this is the simpler parts or components of this expression. So how do we get from this combined expression into decomposing into simpler parts or simpler components of this, which is a simple addition or subtraction that we have seen in the earlier examples. This whole process where you start from here and you end with this partial fraction is nothing but solving the problems of partial fraction. This is the whole process where you start from here and you end from here. So just wanted to level set that the concept of partial fraction, what it means. So if you see here, this looks like a partial fraction of this. This whole thing is a partial fraction of this given problem. That's what it is. And our objective is to get that. How do you kind of simplify something which is more combined and bring into the effect? So that's the notion of partial fractions, and we'll see what are the different types of numerator and denominator that will be in play in terms of rational expression, and how do we kind of simplify those. There are 3 or 4 types typically covered in the syllabus, and we'll talk about that in detail, how to kind of break it down, because the magic is to come from here and all the way to bring it here. So we have to focus what kind of expression is this. In this case, it was easy to solve because it was simple adding and subtracting. But when you are going to do work in the reverse format, when you take this and go back all this, the mathematics slightly changes. And the partial fraction is all about knowing how to break it down, what kind of logic to apply and when to apply based on the nature of the numerator and denominator. That's all partial fraction is all about. So I'll see you more on the next episode with more details.